Let us take another problem where the Kirchhoff's law can be applied. Now you can see the circuit, and in that circuit we have to find the current in each branch. Now you look at the circuit I have redrawn, and in that I have given the direction of current in each branch, and I also named that current also I2, that is I3, I4, I5, I6 and I1. Now I shall apply the Kirchhoff's current law in first in the junction A. Now you can see here I1 is incoming, I2 and I3 are outgoing. Therefore, according to the Kirchhoff's current law, I1 minus I2 minus I3 equal to 0. Therefore, I can get an equation. You can see I1 is equal to I2 plus I3. Exactly in the similarly, I apply Kirchhoff's current law in the junctions B, and here I2 is incoming and I4 and I5 are outgoing. Therefore, we will get an equation I2 is equal to I4 plus I5. Now, similarly, if I apply the Kirchhoff's current law in the junction C, you can see I6 is incoming, I5 is incoming, and I1 is outgoing. Therefore, we will get an equation I1 equal to I5 plus I6. And if you in the junction D, if you apply the same Kirchhoff's current law, then we'll find that I6 is outgoing and I3 and I4 is incoming. Therefore, I6 is equal to I3 plus I4. Now we'll apply Kirchhoff's voltage law. First, in this mesh, ABDA, that means in this mesh. And I have taken the loop's current in the clockwise direction. Therefore, we have to move from A to B, then B to D, and D to A. As we move from A to B, you see first we'll encounter that battery, and therefore we are going from a minus to minus potential and to plus potential. That means negative terminal to positive terminal. That is the lower potential to higher potential. Therefore, it is positive. Therefore, 4 is positive. Now, in the here, it is along the direction of current. I2 and this along the direction of current we are moving. Therefore, it is a minus. That means we are moving from a higher potential to lower potential. Therefore, it is a negative. Therefore, we will get minus 5 I2. Now we'll come to the branch BD. We are moving along the direction of current. Therefore, it is minus 2 into I4. Now into DA, we are moving in the opposite direction of the I3. Therefore, it will be plus. Therefore, plus 8 into I3. Therefore, all together, we'll get the equation. Here, we'll get this equation. This is the equation we'll get. Now, with simplification, we'll get the equation number 5. Now, we'll apply the Kirchhoff's voltage law, the mesh in this loop. B, C, D, and B. Now, as we move we are moving in the clockwise direction. Therefore, if we move in the B to C, therefore we are moving along the direction of current. Therefore, it is a minus 10 into I5. Now, if we come to this CD, branch CD, now we are moving opposite direction of current I6. Therefore, it will be plus 4 into I6. And in this battery, you can see we are moving from positive terminal to the negative terminal. Therefore, higher potential to lower potential. Therefore, it will be negative. Therefore, minus 5. Now, as we go into D to B, in the D to B direction, therefore, you can see we are moving in the opposite direction of I4. Therefore, it is plus 2 I4. Therefore, we all together will, whatever I said, we got this equation. That is this. And here one important thing is that we want to keep only three variables: I2, I3, and I4. And I5, I6, and I1 will replaced by these variables. Therefore, I5 is replaced by the equation number. We'll get it from equation number 2, I2 minus I4. And I6 this has been replaced by I3 plus I4, equation number 4. Now, after simplification, we'll get the equation. They will get this equation number 6. Then, another mesh will take EAB, C, F, E. Therefore, as we move from E to A, there is no resistance. And A to B already I explained. B to C is also I explained. And C to F, there is no resistance. And F to E, you can see there is a battery, and we are going from a lower potential to higher potential. Therefore, we'll get it will be a plus 10. And while in the 1 ohm resistance, we are going along the direction of current. Therefore, it will be minus I1. Therefore together equation will be plus 4 minus 5I2 minus 10I5, and then plus 10 and minus I1. That I am showing here. Here I am applying and showing here. And already I told we'll replace I5 and I1 with this equation number 1 and 2, and then we'll get the equation number 7. Then we'll form the matrix, and from the matrix, after forming the matrix, we'll apply Cramer's rules to solve this I2, I3, and I4. And that how to apply the Cramer's rule. That I have applied the Cramer's rules, and I find the delta 1, delta 2, and delta 3. After that, I found I2, I3, and I4, and then I found I1, I5, I6, the earlier equations. And that is all about this problem.